Hi there, geometry students. This is Mrs. Hefty here, and we're in section 4-6, which is going to focus on isosceles and equilateral triangles. So we learned earlier that an isosceles triangle is a triangle with two equal sides. Let's go ahead and identify our isosceles triangle parts. Our vertex. First off, when I look at this isosceles triangle, it looks like AB is equal to CB. So the angle that is between the two equal sides is called the vertex. The two sides that are equal are called the legs. The side that is not equal is called the base. And the two angles that are on the base are called the base angles. Let's look at the isosceles triangle theorem. If you have two sides equal in a triangle, then the angles. Then the angles opposite are equal. So let me explain that. Here's my triangle. Here are the two sides that are equal. So then the angles opposite would be right here, and the angle opposite would be right there. So they're the ones that are straight across. Those two are going to be equal. Let me write that out. Let's call this A, B, C. So if I've got A, B equaling B, C, then my angle A, measure of angle A, equals measure of angle C. The converse of the isosceles triangle theorem says, well, converse is opposite, so I'm just doing the opposite now. So if you have two angles congruent in a triangle, then the opposite sides are equal. So let me draw that. So I'm just doing the opposite right now, doing the converse. What I'm saying this time is if these two angles are congruent, then the sides opposite are going to be congruent. So in an isosceles triangle, you have two sides that are congruent, and then the two angles opposite are congruent. All right, let's go ahead and apply those theorems to what we know. Oh, we can't forget about equilateral triangle. Equilateral triangle, you know all sides are equal. So here's my equilateral triangle. All my sides are equal. Then you have an equiangular triangle. So then the angles are equal. And so if the angles are equal, I have 180 degrees, and I'm going to split it equally. Each angle is going to measure 60 degrees. So if I have an equilateral triangle, I have the equiangular triangle, and all the angles are equal. All right, now let's go ahead and take a look at our examples. When I look at my notes page, it looks like my numbers did not come through in example number 1. So why don't you take a minute and write M is 112 degrees. MNQ is called Y, and NPQ is called X. All right, so let's dig into this problem. I'm looking at the triangle on the left. This is 112. This side and that side are equal, and I'm looking for Y. If you're thinking Y is 112, that is incorrect. When you have sides that are equal, then the angles opposite. So this angle and this angle are the two angles that are equal. So y is not 112. This angle here is also going to be called y. So these two angles are equal. So now I need to go ahead and use my sum of my triangle equals 180. 112 plus y equals 180. Get your like terms together. 112 plus 2y is 180. Move your 112. 2y equals 68. Divide by 2. Y ends up being 34. So that's one of my variables I'm looking for. I'm going to go ahead and clear my diagram so I can see a little bit better here. So this is going to be 34, and this is also going to be 34. Now when I want to find my x, I really need to be working with this triangle over here. So let me pull that out. These are the two equal sides. This is x. Now if this is 134, you can go ahead and find that angle by subtracting from 180. So I'm going 180 minus 34, and I'm getting 146. Again, if you're thinking x is 146, that's incorrect because you have these two sides being equal. So opposite the sides are going to be the equal angles. So this is x. So once again, I'm going to use my 180 degrees to add them up. 146 plus x equals 180. 146 plus 2x is 180. 2x equals 34. And then divide by 2x is 17. Now let me talk about something here, people. I don't know if you noticed this or not. I'm going to clear my diagram again here. I knew this was x because these two are equal, right? Look at this here, people. This is an exterior angle right here. That's an exterior angle. And remember that an exterior angle equals the two remote interior angles added together. So let me draw that out here. This is what I got. This is 34, and that is x, and that is x. So we learned that the exterior angle equals the sum of the two remote interior. So this is a remote interior, and that is a remote interior. So I could have done x plus x equals 34, 2x equals 34. Do you see this? I'm getting the same thing I got down here. So it's kind of like a double checker. So I'm getting x equals 17 again. Let's take a look at example number 2. All right, this time I'm given all three sides and I'm given two angles. I need to find the value of x, so my expressions are on my sides. I need to set two of these equal to each other. Which two am I going to set equal? Well, I know one is 40 and I know one is 70, so I have 70 and 40 gives me 110, so that makes this angle 70 as well. 180 minus 110 is 70. So at that point now, here are my angles that are equal. So I'm looking to my sides opposite. So I need to use my 6x, and I need to use my x plus 25. So I'm going 6x equals x plus 25. You can't just guess. You've got to know why you're doing that. Move your x. 5x equals 25. X equals 5. All right, let's move on to example number 3. In example number 3, I have an isosceles triangle. Once again, don't assume that those two are the equal angles. Look at your sides and go opposite. Side and opposite. These two angles are equal, and there's nothing at that top angle. So I need to write, well, it's equal to this one, right? These two are equal, this angle and that angle are equal, so I'm going to write my x plus 30 there as well. Now I know all three angles, so I'll add them up to 180. I've got x plus 30. I'm not combining my terms. I'm explaining everything here. I'm communicating my mathematics. Here's my first angle. Here's my second angle. Here's my third angle to equal 180. Okay, so I've got x, x, and x combining my like terms. That gives me 3x. 30 and 30 is 60, and that equals 180. So 3x equals 120, and then x equals 40. And if I wanted to, I could go ahead and plug that all into the expressions that represent the angles to see if that works out as a double checkers. Let's look at example number 4. This time you're given two angles congruent and you're given the sides. You need to decide which two you're going to set equal. Once again, you've got to look. Here's your congruent angle, so opposite and opposite are going to be equal. The opposite sides are going to be equal. So in this example, I'm going to take 4x minus 6 equals 18. Oops. And then I've got 4x equals 24. So I'm getting x to equal 6. All right, so there you have it. Be careful on those isosceles triangle ones. I can see very easily that somebody might have taken 4x minus 6 and set it equal to 16. So you guys have a great night, and I'll see you in class tomorrow.